May the 27th, 2019. Happy Memorial Day, everyone. Be very careful and remember all the people that sacrificed so that we would be free and enjoy this holiday today. Don't forget that, guys. Don't forget it. Many nations cannot do what we do or have the freedom to do what we do. But a lot of sacrifices went down because of that. Now, you're looking at our magnetopoles. The Earth is in the center, and the white side of that circle is the sun-facing or daylight side of our planet. This is our magnetopoles. And notice your timestamp yesterday, 26th. This is called a standoff point. Normally, it's right here at about 12 if you have just average solar activity. It's a little wider than that now because the magnetopoles is almost a living organism. It can sense when you have an interplanetary magnetic wave coming at our planet, and it will react to that and actually expand. But look what happened before the day was over. That collapsed because, again, an interplanetary magnetic wave occurs often, but it just depends on the strength of it and the weakness of our shields. It has to do with the rotation of the Earth going around the sun as the sun rotates. So you've got some mathematics in there. But going into today, look at the energy building up. We have not seen the worst of, or the strongest section as far as density and plasma of the wave yet. You can see it's building. We'll look at another chart, guys. Now, again, our standoff point was very close to 13 when we started the video there. And again, average is 12. But now you're down around 8, 7 in there. That's just the pressure coming from the sun that you see. Now, there's some things that are changing. Our magnetic poles on the planet and the sun's magnetic poles, not the physical poles, but they're shifting. And it's causing some changes. As this planetary wave moves through, you'll see that the energy is not coming directly from the sun to the right. But look at what's happening now as we start to move into that deeper section of this wave. And it has to do with density and protons. So many of you are aware of that. But guys, look at the collapse at the top part. Notice also that this energy is not coming directly from the sun. This is a wave, and it spirals out like a rope tied to a merry-go-round or something, guys. It just bends back, but keeps coming. So the angle, that's why this angle is different. The energy is coming from the bottom right corner because of the way the wave is striking us from the sun. So again, it's not coming directly as far as you looking at the sun. This wave is left and is coming around for a broadside. And so you're seeing that energy shift. Check this out. Top has collapsed tremendously. It reminds me of when CERN was cranking up. But that energy, again, because of this wave traveling around the sun and whipping around, is catching us from the side. It's amazing to watch. It's coming from this direction and burning off on the back. But we'll look at it on the other charts. But it's amazing to see this. Now, notice your timestamps here. This 8-point quake struck yesterday as we started entering into that field. The sensors can sense this coming. Sometimes if the energies in these waves are a solar flare or something is so intense, the satellite sensors can actually shut down a lot of their activity to preserve the electronics so they don't get overloaded. But this 8.0 quake, this was 75 kilometers south-southeast of Lagunas, Peru. Very strong. There was a lot of liquefaction in this. The soil just kind of crumbling, guys, and a lot of buildings were damaged. There was not a lot of life lost, but there was a lot of infrastructure damage on it. Now, going into today, 5.8s, 5.5s around it. And this one up in Alaska, 5.8. That one is one to watch simply because the scientists have said that just below that, the Cascadia fault zone is overdue. The pressure's building. And that had to do with the 8-point quake yesterday down in South America. As the pressure built from this incoming wave, and you can see where the satellites picked it up here, sudden jump. The bottom is temperature of the wave. The purple line second from the bottom is the speed. The orange line here, this density, it's protons, centimeter cubed. They it quadrupled. If you look at the numbers, starting out around 10 and it drops down to about 8, then suddenly jumps up, guys, to almost 30. That impact and the building of that impact caused that shift in that plate. It's one of the Nazca plates that we're talking about in South America. But this interplanetary wave, if you look at it, look at the bottom globe, and you can see the Earth, the sun's in the center, and the Earth is to the right. But they both charts, the Earth is in the same location. You can see this green area of this wave that we're getting into. And on the bottom, same thing, just looking at radial velocity and plasma density. Okay, speed is here in the green line on the bottom right. Notice we are not in the strongest wind speeds yet. This is the 27th right here. And this wave that's coming is this entire green and yellow section. So it's coming in yesterday. We see it hit our planet here. But again, we will see this going in through the 28th as far as density, and I think that's what caused that quake. Our solar wind speed, though, is going to increase and up until the 30th. So we got 3 more days, and you're going to see 500 or so kilometers per second, which is, as it bumps up and down, you're averaging 1,000,000 miles per hour. Very fast. So that speed is, you really can't comprehend it, guys, if you think about 1,000,000 miles per hour. So you can see why our shields will bend like that. And again, what's interesting to me on these waves are that they catch other. The density increases when the solar wind decreases. In other words, you have I call it the smoke effect. If you have a fire and you've got a certain amount of smoke that's being released, if the wind picks up, it blows that smoke away, and it doesn't become denser, it becomes less dense. You've got more fresh air mixed in with it. Same thing with plasma density. If the solar wind is fast, the plasma density is low because it's being pushed and blown apart so fast. But when the radial velocity is low, or the solar wind speed is low, like we're seeing today on the 27th, the density or the smoke effect is thicker, because it's not being blown away. It's not being mixed with the fresh air, if that makes any sense at all, guys. But so as your solar wind speed picks up here on the 30th, you'll see at that same time the density will decrease. But that's what we're dealing with. So it's, I think the major quake, I hope, has happened as we saw the pressure start to build on our shields. But we're not in out of the thickest part of it yet. That's going to occur tonight around midnight, and it will last. You see, it will kind of pick up, and the speed will not peak until the 30th and the 31st, but the density will decrease. And I think that has as much to do with the pressure on our planet as the speed. But when they combine and our shields are weak, we have to be watching this. Normally, an 8.2 quake like that, guys, you have a solar flare, coronal mass ejection, or something like that. But this is simply again, interplanetary magnetic wave. And if you look at the way this thing spins, you can see how the green and yellow lines come out of the center, which is the sun. That sweeping effect has to do with our planet. It looks stationary here, but our planet's rotating. But so the waves are in that model, and this is stupid.